Hello, today we are doing mission 3, which is looking at both surface area and volume. So we're going to look at a different question on each slide that's a word problem, and we need to decide, are they asking us about surface area or are they asking us about volume, and then actually solve the problem. So on your homework, don't just circle surface area or volume, you actually need to solve the problem too. So first it says, Tommy and, oops, it's supposed to say Ethan, that's my mistake. Should say Ethan, each have a cylinder. Tommy's cylinder has a diameter of 6 inches and a height of 8 inches. So I'm going to label it right now because here's Tommy's cylinder. Diameter of 6, so remember that goes all the way across, and a height of 8. Ethan's cylinder has a diameter of 8. You can label the top or this bottom circle, doesn't matter, and a height of 6. Whose cylinder requires more metal to make? Okay, so this phrase right here, the sentence, gave us the answer to whether or not we're looking for surface area or volume. It's not filling it up, it's how much to make it. So if we were going to lay this flat, how much material would we have? So we're talking about surface area. So our formula for surface area is 2 times the area of our base, and the area of our base is a circle, so pi times radius squared. This will give us the area of the base. Plus, we have to find the circular part that goes around the edge, which is really the perimeter times the height, but in a circle we call the perimeter a circumference. And our circumference, you don't need to write this word. Circumference is pi times the diameter, and then we need to multiply that by our height. Alright, so let's plug this in for both Tommy and Ethan. So first, for Tommy, we have 2 times pi times our radius. Okay, so it said our diameter was 6, so our radius is half of that, which would be 3. So we have 3 squared, plus pi times our diameter, which is 6, times our height, which is 8. So we're going to plug in this in our calculator and then plug this in our calculator. First, I'm going to plug in 3 squared because I don't have a graphing calculator in front of me, or a smart calculator. It gives us 9 times 2 times pi, which is 3.14. So it gives us 56.52. I'm using for pi 3.14. Plus pi 3.14 times 6 times 8 gives me 150.72. So altogether, my surface area of that cylinder, adding up those two pieces, is 207.24. We're talking about inches squared for surface area. So that's Tommy's cylinder. That's how much metal he would make, or need to make that cylinder. Let's look at Ethan's cylinder. Same formula down here. So we have 2 times pi times our radius squared. Okay, our diameter is 8, so our radius is 4. So we have 4 squared, plus pi times diameter, which is 8, times our height, which is 6. So we're going to plug this in 2 separate chunks. Now this one over here we did pi times 6 times 8. Pi times 8 times 6 is the exact same. So I already know this part is 150.72. This is what we call a commutative property. Doesn't matter which order we put them, you'll get the same answer. But the first part we do need to plug in our calculator. So 4 squared is 4 times 4 times 2 and times pi 3.14. I get 100.48. Decimals down here. So just by looking at these answers, I know that Ethan is going to have a larger cylinder, so his would require more metal, but I am going to add them up. we get 473.2, oops, I think I made a mistake. Yep, that doesn't make any sense to get 400. 100.48 plus 150.72 gives us 251.2. And again, we're talking about inches squared. So, whose cylinder requires more metal to make? Ethan's does. So I put a star by his name, or you could put Ethan over here. All right, slide 2. A cylindrical wafer biscuit is filled with chocolate. These are really good. I love them. If the inner radius is 4.5 millimeters and the wafer is 10.3 millimeters long, how much chocolate is needed? So it's filled with chocolate. So we're actually looking for the volume. So volume is area of the base times the height. And I'm just going to draw a picture here of a cylinder. They told us the radius is 4.5 and the height is 10.3 millimeters. So area of the base is a circle, which is pi times radius squared, and then times our height. So again, pi times our radius, which is 4.5 to the power of 2, times the height, which is 10.3. So I'm going to plug this in, 4.5 squared first, because I don't have a fancy calculator. 4.5, and then times pi, 3.14, and times 10.3. You know, this is our multiplication and this is multiplication. These other ones are decimals. And we get 654.92. I'm going to double check that. 4.5 times 4.5 times 1.3. Yep, 654.92. Oh, it's 925, so I could round it up to 93. And we're talking about millimeters cubed. Since we're talking about volume, it's a three-dimensional shape. And that actually makes sense because a millimeter is really, really tiny. So there's a lot of little bits of chocolate inside there. Flip over to the back side. We have two more questions. How much water is needed to fill, keyword there, fill. We're not looking about flat. We're talking about a volume, three-dimensional, like water. How much water is needed to fill a jug that is 7 meters deep and has a radius of 9 meters? So here it's 7 meters deep and has a radius of 9. I know it's kind of hard to look on there. Maybe you can put this over here. This side might be easier to see. Come on. Radius of 9. So volume again is area of the base times the height, and our base is a circle, pi times radius squared. So we have pi times our radius, which is 9 squared, multiplied by our height, which is 7. So I know 9 squared is really 9 times 9, which is 81, so if you just want to use that, you can. Times 3.14 and times 7. And we get a volume of 1,780.38 meters cubed. That's how much water would be needed to fill this ginormous thing, cylinder, whatever you want to call it. Last question. Diana wants to make several cans with a diameter of 6 inches and a height of 8 inches. So I'm going to label this. It says diameter across is 6 and a height of 8. She's going to cut the cans from a sheet of metal that has an area. So this right here, this whole sheet of metal that she's looking at, has an area of 2,675 inches squared. How many cans can she make? So we're talking about surface area, flat. We need to first figure out how much surface area does this can require so we can figure out how many cans we can make. So our surface area is 2 circles. First we have top and bottom, 2 circles which area of a circle is pi times radius squared, plus the distance around, perimeter times the height or circumference, pi times diameter times our height. Okay, so plugging in everything that we know, 2 times pi times radius, our diameter is 6, so our radius is 3. Radius only goes to the middle, so 3 squared, plus pi times diameter, which is 6, times our height, which is 8. We need to plug in each of these separately and then add them together to find our surface area. So 3 squared, 3 times 3 is 9. We could do some of this in our heads. 9 times 2 is 18. It's all multiplication, so it doesn't really matter what order you multiply in. We get 56.52. We get that answer quite frequently. And then pi, 3.14 times 6 times 8, 150.72. So the surface area of one can is 207.24 inches squared. So this is the surface area of one can. They want to know how many cans she make. How many cans can she make? So if we know the area of the whole piece of metal is this right here, we could just divide it by one can to figure out, well, how many cans of this size could we get? So we're going to divide by 207.24 to see how many of that size could we make out of the sheet. So 2,675 divided by 207.24, I get an answer of 12.9 if I round it. You can't have 0.9 of a can, so we would round that to about 12 cans. We could make 12 full cans. They'd be close to making another one, but not enough material. Alright, your homework, you have to decide whether you are looking at volume or surface area. Circle your answer, write down the formula, and then actually solve it. Okay? You have 4 questions on the front